Hello everyone, welcome to the control system. This is part 4 of lecture 5 block diagram. So in this section we will be discussing on the closed loop system subjected to a disturbance. So let's consider the system shown in this figure. Okay, we have the reference signal, we have the output HS. HS can be considered as a sensor. G1S can be considered as a controller. G2S can be considered as a plant. And there's a disturbance come into the system. So this is the reference input, is a desired value. It can be desired trajectory of something. It can be a desired trajectory of the drone. For example, you want a drone to follow any prescribed trajectory. And this is the controller. Okay. Well, perhaps there are many subsystems inside this. If we consider the drone, for example, there will be the position and the attitude control. Okay? And this is G2S. As I said, you can consider as a plan, basically the dynamic of the system. Okay? In the simulation, it's a mathematical model, and in practice, it is a real hardware. Okay, and there is a disturbance here introduced into the system. So nothing is perfect in the real world, and there are two types can be considered, or maybe more. Okay, uh, there are internal disturbance and external disturbance. So internal disturbance come from the actuators. Maybe there's a friction, thermal conductivity, or something. And external disturbance, if you consider the drone, as I said before, uh, the wind or drag can also consider as external disturbance. Okay, it come into the system, and in practice, you may have this noise will also introduce into the system. Okay, in this case, we consider normal case, so it we include this into this HS already. All right. So in the closed loop system that's subjected to disturbance, if we want to examine the effect of the disturbance, and we may assume that the reference input is zero, okay? And then we may then calculate the response CDS, the response that only uh, consider the disturbance, not the reference input, okay? And this the response can be found like this in this equation, okay? And I will leave you as an exercise for you to find uh, this ratio between CDS to DS. Okay, we assume that there is no reference input, so just take the signal out, do a little bit of manipulation, and then you will be able to find this. Okay, for exercise, maybe 10 minutes to get this. Okay, is enough. On the other hand, in considering the response to the reference input, COS, we may assume that there is no disturbance. Okay, remove this signal out, and then the response CR, which is the response to the reference input, can be obtained by this one. Okay, the same way as we did to this system. So in this case, we just take the DS out. Take this one out. Take this signal out, and then do a little bit of manipulations using uh, what you have learned in the previous part. And I'm sure you can find this. Okay. So the response to the simultaneous application of the reference input and the disturbance can then obtain by adding to individual response. Okay, because this is an LTI system, so linear time invariant system, we can add this signal together, and then the response ES can be obtained like this. Okay, so far we have this ratio, CDS over DS equal to this one, and CRS over RS equal to this one. And now let's consider now that the case where this value is much greater than 1. Okay, and also this value is way greater than 1. What happens? Okay, so if this case, if we consider this case and this case, then the closed loop function, this one, will become almost 0. Okay, because this is very big. Okay, much greater than 1. So when this value is very large, and then this ratio will become almost 0. So the effect of disturbance is suppressed. Okay, there is no disturbance at all. So this is a good for closed loop system. Okay, and in this case, the CRS over RS will approach 1 over 8, okay, because this is so small compared to this, and you can just take the limit if you want, and the only remain is 1 over HS. Okay. So this means that if this value is way greater than 1, it's much greater than 1, then the closed loop function uh, CRS over RS become independent of G1 and G2, okay, and inversely proportional to HS. Inversely proportional to HS, it means 1 over HS. Okay, so that the variation of G1 and G2 does not affect the closed loop transfer functions. Okay, and both cases good for closed loop system. So we want this value to be much greater than 1. Also this one. All right.